All right, Chapter 5, Curve Fitting with Quadratic Models. This is a fantastic topic, and I really do enjoy this topic because it really gets to modeling the real world with data. And that's what math is. It's how do we describe the world that we live in mathematically in a way that helps us to make predictions. So, our learning targets today, I can use quadratic functions to model data. I can use quadratic models to analyze patterns and make predictions, and I can use technology to create a quadratic model from data. Yes, technology is in there. First, it's part of the standards that the state and nation provide. Second, it's part of my standards. And third, that's how we're going to do it in the real world. So learning these things that we would use is very important. In class, we'll use graphing calculators, but there's many forms of technology, whether it's Excel or other computer programs or mathematical software that people use to do this type of stuff. So, first thing, identifying, is it quadratic? There's two ways of doing this. The first way, we can look at a table. The second way, we can graph the points. Looking at a table is by far the better of the two ways. It is more accurate if we can do it. But there are times when looking at a table doesn't actually work, and we'll see that in a minute. So if we look at a table, the first thing we need to look at are the x values. We want to make sure the x values are all going up by the same amount each time. If they're not all going up by the same amount, we have a random assortment of points, we're not going to be able to look for patterns. That's when you need to graph them. If your x values don't go up, graph them. So once we've looked at the x values, we can then look to see what are the y values doing. So from -4 to -1, it's +3. From -1 to 2, it's +3. 2 to 5 is +3. 5 to 8 is +3. These are what's called the first differences. We can notice here that these numbers are all the same. If the first differences are all the same, that means that this function is linear. Notice the slopes. 3 divided by 1, 3 divided by 1, 3 divided by 1, 3 divided by 1. A linear function is a function where the slopes are all the same. And so, this one's linear. Is it quadratic? No, it's linear. So let's look at another one. First thing we need to look at are the x values. Are they all going up by the same amount? In this case, yeah, they're all going up by 2. It's not 1, but that doesn't matter. They're going up by the same amount. So now we can look at the y values. When we look at the y values, the first one from -1 to 2 is 3 again. 2 to 11 is 9. 11 to 26 is 15. 26 to 47 is 21. So those are not the same. Our next step, look at the differences between these. How do we get from 3 to 9? And 9 to 15, and 15 to 21. From 3 to 9, we add 6. 9 to 15, we add 6. And 15 to 21, we add 6. These are what are called the second differences. We can notice here that these differences are all the same. The second differences being the same means that this is quadratic. We're going to continue this pattern next chapter. The first differences means a linear, that would be x to the first power. Second differences being the same as quadratic, that's x squared. If the third differences are the same, it means it's going to be x cubed. If the 17th differences are the same, it means it's going to be x to the 17th. We're not going to get that far, but we could. And really the only thing that limits us is the number of points that we have. Obviously our third differences here, we're only going to have 2. The fourth difference, we're only going to have 1. Well, 1, we don't have enough numbers to compare it to anything, so we would need more points to do that. But right now, the questions are going to be, is it quadratic or is it not quadratic? So are the second differences the same or not? So we'll give you one to try. Try this one. We have the table. Check out your differences and figure out if it's quadratic or not. Go ahead and pause the video and push play when you're done. So is it quadratic or not? Well, let's check. The x's are all the same. So let's look at the y values. 1 to 3 is 2, 3 to 9, 6, 9 to 27 was 18, 27 to 81 is 54, so it's not linear. Okay, and then let's look at the other ones. 2 to 6 is 4, 6 to 18 is 12. Already, that says not quadratic. We could find the third one to be 36, but what this is not quadratic. What is it? This one happens to be an exponential function. We'll see those in chapter 7. But right now, it's not quadratic. That's what's important. So what if these x values don't go up by the same amount? We're going to graph them. So here our x's go from 0 to 1, that's plus 1, then plus 3, then plus 1, then plus 3. There's a pattern there, but it's not what we're going to be able to use to figure out whether or not it's quadratic. So we're just going to graph the points. We need a graph that's an appropriate sized graph, and then plot our points. And so here looking at this, does it look like it could be quadratic? Yeah, it looks like it could be a parabola. We could draw it going down and coming back up again. And that's where this method struggles, because it looks like it could be quadratic, or maybe it doesn't look like it could be quadratic. It looks like it could be linear. Well, if we're not looking around the vertex, quadratics do look a little bit linear. This one is in fact a quadratic. It was x minus 4 squared, then minus 5. We could draw it if we want to, but you can see that it can form a quadratic there. So yes, this one is quadratic. You can tell by graphing. It's not the preferred method, but sometimes that's all we can do. Well, how would we make a quadratic function? We have two different methods. We have one from 3 points, and we'll have one from more than 3 points. From 3 points, we're going to take our 3 points, and we're going to plug it into our general form of the quadratic equation. Y equals ax squared plus bx plus c. This is going to create a system of 3 equations. Now notice here, I didn't have y equals, I put the y over here. That's okay, I'm putting it there for a reason, and we'll see that in a minute. But first, let's plug in our points. We'll have negative 2 in for x, we'll have a times negative 2 squared plus b times negative 2 plus c equals 5. And we'll do the same for other 2 points to make a system of equations. From here, we can simplify. These numbers get squared, and these numbers just multiply. So we can simplify to an equation like that. This is the same thing we were doing at the end of chapter 3. And so we could solve this using elimination. As far as systems of 3 equations go, these are generally pretty easy to solve. First of all, the c's are always just one c. And so the c's are always easy to get rid of. In this case, the b's are really easy to get rid of too. And so these do solve pretty well. But in chapter 4, we learned another method. We can turn this and put this into a matrix. And that is why up here I have it equals y instead of y equals. Because for a matrix, it has to be in this form with equals a number on that end. It's also easier to solve systems of equations that way as well, but it's necessary for a matrix. So we can put it into an augmented matrix, and then we can solve this. We solve these using our graphing calculators. And so you can pull out your graphing calculator if you have one. If not, I'd watch this again while you do have one so that you can remember what we do. Then the first thing we need to do is we need to put our matrix into the graphing calculator. To do this, you need to wait for the video to catch up. Anyway, to put our matrix in, we're going to go second, and then x to negative 1. It says matrix right there. There we go. So we're going second to the matrix. The names, that's just where we have them named. We're going to go over to edit. That's where we can change our matrix. So select it. Our matrix is a 3 by 4 matrix. We have 3 rows, 4 columns. We have 3 by 4, and then we have to enter it in. Just enter it in exactly as you have it. You should really be able to enter this matrix in faster than I can do it with the mouse. I know someone asked about the arrow button. They said, well, if you push enter, it moves it as well. True. I use the arrows just out of habit. There's really no difference between them. So we're getting our numbers entered. Again, make sure the Y's are on that far right-hand side. And once we have the matrix entered, we want to quit out of the matrix because we don't want to do something inside the matrix when we didn't mean to. That's generally a bad thing. So to quit, we are going to push second, and then mode is quit. So we're going to go second, then mode. And that quits out of the matrix. Now we need to get back into the matrix. I wish there was a way to just go backwards, but I've never found it. Hey, look, there's our matrix there. It's a 3x4. We're going to go over to the math side, the math menu. So we need to push the over arrow and then scroll down. When we scroll down, we'll get to something that says REF. That's row echelon form. That's not the one we want. We want RREF. That would be reduced row echelon form. And so we can select it. And then we need to enter the matrix back in there. So go back to the matrix menu. And here's where we select it from this first screen. I have my matrix as matrix A. And then hit enter. And we get 1, 1, 1, and then 1.33, negative 1, negative 2.33. We have some fractions there. They're kind of ugly. Well, those ones aren't. 0.3 repeating. That's just 1/3. So we're going to change those to fractions in a second. Right now, notice, though, this x 1, 1, 1, that used to mean x equals 1.33, y equals negative 1. Right now, it's a, b, and c. Those are the variables in our equation. So to change these to fractions, we're going to go to the math menu. And the very first thing here, to fraction. We're just going to hit enter. It's going to change our answer into fractions. Hit enter, and look, that's way more pleasant. I know that the thirds here really wasn't that bad, but they might be more unpleasant than just thirds in the future. So it's good to be able to do that. And so what this says is that A is 4/3, B is negative 1, and C is negative 7/3. So we're just going to take our equation, ax squared plus bx plus c equals y, and plug in those values. And then if you really want to, you can change it to y equals. It doesn't make a difference, but I know that when we look at it, it's nice to see y equals blah, blah, blah. It's just our function notation. And so that's how we can make a quadratic function from 3 points. Now, if you have 3 points, you do need to do it this way. Any 3 non-collinear points, you can draw a quadratic through. If you have more than 3 points, we're going to use regression. That doesn't work for this so well because it estimates things, and so your numbers aren't going to come out to be that nice. So from many points, many would be more than 3. In our case, we have 5. The only difference between 5, 6, 57 points is how long it takes to enter them into your calculator. So we'll start with 5 because we don't need to spend a lot of time entering. So we have our points. Then we have 5 steps to doing any kind of regression question. And these 5 steps don't have anything to do with what kind of calculator you have or what kind of technology you have. These are the 5 steps that you always do. How you do each of those steps that'll depend on what technology you have. The first step we need to always do is we have to enter the data. You need to tell your technology, your calculator, what you're working with. Secondly, graph the data, because getting that visual will help us know what type of function we need. And it'll also be it's a good way of checking to make sure we didn't make a mistake entering in our data. Step 3, do the regression. This is the only step that'll change between whether you have a linear function, quadratic, cubic, quartic, any kind of regression. Which one you pick, that's the only step that changes. Step 4, we want to check the graph. Does our graph match, does our model, our line, our equation match the graph? And then step 5, answer the question. And so, pulling out our calculator once again, and if you have a calculator, I would have it out following along here. If not, I would plan to come back and watch this. So the calculator that I have access to here is a TI-84 Plus, and it's the color one. It's a really nice one. These are great. Other calculators are just fine too. The Casios, it's really easy to do regression on the Casios. TI-83s, it's a little bit different than this. It's pretty much the same, but there are some changes. But this is the one that I actually have access to on my computer, so here we go. The very first thing that we're going to need to do here is we need to enter the data. To enter the data, we're going to go to the Stat menu. The Stat menu is this guy right down here. Pretty soon our video is going to catch up with us. There we go. We can go to the Stat menu, and we edit. Edit our data is how we enter it. I already have data in here. I need to clear that. So I'm going to go up to where it tells me my list, and I'm going to push the clear button. Don't push the delete button. If you push the delete button, your list will just disappear. You push clear, then you go down, it disappears. Do it for the same for list 1. Down, disappears. If you do happen to clear it or delete it, you can go into the Stat menu. Number 5 is set up Stat Editor, and just hit enter a couple times, and you should be good. So, entering our data. We just need to enter it. It just needs to look like our lists over here. X is 1/4. People always ask, well, how do I get a fraction in there? And some people find a fraction option in the math button. 1/4 is just 1 divided by 4. It even looks like 1/4. Remember, the division symbol is a fraction. We go down, it changes it to a decimal force because it doesn't like to show a fraction in that little line. That's okay. Just keep entering them. You can change them to decimals if you want. These ones aren't all that hard to do, so you can do them in your head. Or you can just enter the fractions. But just enter. You guys should probably be able to enter this faster than I can on the computer. Move over to the list 2. 98, 156, 208, 277, 371. All right. Now that we have it entered, we want to graph the data. To graph it, we need to go to Scatterplot. Scatterplot is going to be the second y equals button. Notice it's in this different color above y equals. For me, it's blue because my second button is blue. Those are some green ones, like it's our alpha. Yours might be different colors, but it's still set up the same. And when we go into Scatterplot, the very first thing we're going to need to do is we're going to need to select one and turn it on. One of the biggest mistakes, or one of the biggest questions I get is, hey, I graphed it, but it's not showing up. Well, did you turn it on? A lot of times the answer to that is no. It's kind of an important thing. So make sure you turn it on. And then the type of graph, we want a scatter plot. That's the very first one. The rest of them, most of the rest of them we'll get to throughout the year. But right now we're just really worried about the first one. Our X list and Y list. I put mine in list 1 and list 2. You could have put it in other lists. It's easy enough to change. It's just second, then whatever list. For instance, if you put it in list 5, second 5. Now the mark, this is personal preference. I think the square is too big, that dot is too small, that little dot is right out. So I like the little cross. Color is also personal preference if you have that option. So once we have it set up, we're just going to graph it. We hit graph, and we don't see anything. If we remember what our data looks like, the X's were really small, and the Y's were in the hundreds. And so we need to zoom this. So we're going to zoom. That very bottom one, zoom stat. Scroll down to that, or just hit number 9. And there's our scatter plot. I know it looks like it's pretty linear right there. But if you were to graph a line or put a straight thing up against your screen, you'd see that it has a little curve to it. You don't really see that until you put something straight right there, though. So we have our points. Now we're going to do our regression. To do our regression, we're going to go back into the stat menu. Back into the stat menu. Then we're going to go over to calc. This is where we see all of our regressions. Number 4, linear regression, ax plus b, we did that in chapter 2. You'll be doing that some today as well. Today we're going to look at quadratic regression, which is number 5. Next chapter we'll see cubic and quartic regression. Then if we scroll down a little bit, we have ln, that would be logarithmic, and the one below that's going to be exp for exponential. We'll see those two in chapter 7. The power regression and logistic regression, we won't see this year so much, but you will see them next year in pre-cal. But right now, we're dealing with quadratic, with possible some linear regressions in there as well. So 4 and 5, so quadratic regression. The 84s is great because you get this menu. If you have an 83, an older model, it's just going to say quad reg, and you have to go L1, comma L2, comma Y1. It's not as user-friendly. I can help you with that individually if you need. But here we're putting in our lists. I have my data in list 1 and list 2. The frequency list, we don't need. Store regression equation. This is going to put our equation directly into our y equals menu. So we want to go down there, and to get y1, we're going to go alpha, and then F4, alpha trace. And look, there's all the y's. We're going to put it in y1. If we wanted, we could put linear in y1 and quadratic in y2 to compare them. That'll be really important in the upcoming chapters. Calculate, we get this. Y equals ax squared plus bx plus c. A equals 101.7. Just round it, 101.7. B equals 114.2. C equals 66.4. So we just plug those into our equation. Y equals 101.7x squared plus 114.2x plus 66.4. The r squared is how close is it? The closer to 1 that r squared number is, the better model it is. 0.9978 is really close to being perfect onto our data. And so to check that, we can just graph. The stat plot's already set up. We graph. It's right there. It's almost hitting each of those points. Isn't that a wonderful fit? Now, it's not going to hit every point because real world data is not perfect. It just won't be. Even in something like physics, where it should be perfect, we get measurement errors, rounding errors. There's all sorts of things that make it so it's not perfect. That's okay. We're not looking for perfect. We're looking for close. And so we have this that's close. We've checked our graph. We can get our equation is y equals 101.7x squared plus 114.2x plus 66.4, as we saw. I'd make sure to write that down before you graph it, because if you once you graph it, if we were to go back, it wouldn't be there. We'd have to do the regression again, which isn't a big deal. It's just it gets obnoxious. Then finally, we just need to answer the question. If the question is find a quadratic model for the data, we did that. That's the equation. If it is make a prediction, what will y be when x equals 2? Plug in 2. What x value would give us a y equal to 200? Well, make y equal 200, move it over, deal with the quadratic. In this case, I would go with quadratic formula because those numbers are ugly and I wouldn't want to try and factor them. But just deal with the quadratic. But make sure that you answer the question. That's one of the big mistakes people make. They get the equation and they're done. It's like, hey, that was part A. What about part B? So the audio here should have been a lot better. And I will see you in class.